Next important economic function that we are going to discuss in this class is the production function. Production function is a technical relationship between the amount of input that a firm uses and the maximum level of output. Or simply, it is a technical relationship, or production function shows the technical relationship between the input and output. Output is thus a function of input. The mathematical form of production function can be specified as Q equal to a function of various input, labor, capital, raw material, technology, etc. This is the mathematical form of the production function. It represents the technology of a firm, and the general mathematical form of production function is Q equal to, this is an example, Q equal to 12KL minus 6K square minus 3L square, or Q equal to K raised to 0.2 L raised. These are various forms of production functions. That is, it states the maximum quantity of output that can be produced with a given quantities of various inputs, and it shows the amount of product that can be produced with the most efficient combination of factors. It measures the marginal productivity of a particular factor of production. That is, marginal productivity of a particular factor of production or input is measured through the production function. A graphical representation of production function is shown here. As labor increases, here input and output, a functional relationship between the labor and output is given here, keeping capital as constant. As labor increases, output also increases. And the slope of the production function gives the marginal product of the inputs. Different forms of production functions are given here. We have additive form like this, Cobb-Douglas production function, CES production function. These are the various forms of the production function. And the most popular form of the production function is the Cobb-Douglas production function. And it is widely used to represent the technological relationship between the amount of two or more inputs, particularly physical capital and the labor, and the amount of output that can be produced within those inputs. It was developed and tested by the Charles Cobb and Paul Douglas during the period 1927 to 47. This was their study period for the empirical examination of the relationship between the capital and labor and the output. And he has given the following functional form of the production. Cobb-Douglas production function as Q equal to A K raised to alpha, L raised to beta. Q is the total production, L is the labor input, K is the capital input, A is the total factor productivity. Alpha and beta are the output elasticities of capital and labor respectively. These values are constant and determined by available technology. We have different types of production function like short-run production function and long-run production function. In the short-run production function, at least one input is fixed. Short-run production function is known as the law of variable, or the theory applicable during the short-run period is the law of variable proportion. Here the feature is that at least one input will be fixed. Whereas in the long-run production function, all inputs are variable. The long-run production function is known as returns to scale, or the theory that explains the long-run production function is termed as the law of returns to scale. A brief explanation of law of variable proportion is given here, where law of variable proportion is applicable in the case of short-run production function. The relationship between the average product and marginal product and total products curves are explained through the law of variable proportion. Total product, average product and marginal products are related in different ways. Their relationship is different in different stages of production. Explains the relationship between total product, average product and marginal product. In stage 1, marginal product begins to decline, but average product reaches its maximum and marginal product curve cuts AP at its maximum. And the second stage is at the stage where average product and marginal product both falls and a marginal product equal to 0, then total product will be the maximum. And stage 3 is MP is negative. Marginal product starts declining or negative. Total product and average product both falls. Laws of returns to scale. In the long run, the law of returns to scale is applicable. In the long run, all factors are variable, and the law of returns to scale may be explained like this. Suppose all inputs are increased by 10%. There are three possible outcomes. If output increases by 10%, it is the constant returns to scale. If output increases by more than 10%, it is the increasing returns to scale. If output increases by less than 10%, it is decreasing returns to scale. These are the three different stages of prediction according to the law of returns.